And anybody have questions on anything before we start to refresh a little bit? Anything from last class or anything of the such? Okay, so if you've just dialed in now, welcome back to MAT130. We're going to start doing the exercises, subsets, proper subsets, and subsets, proper subsets, and the concepts of those will get us ready for set operations. Okay, so I'm going to go ahead, I'm going to share my screen here. And one thing I'm going to ask is if you're not speaking, please mute your microphone because we're starting to hear a lot of background noise of like voices in the voices in other rooms and stuff like that. Okay, here is what I need to share. And you guys should be able to see a big purple splotch on the screen right now. So if you can't see that, let me know because it means something's wrong. And I need to make sure that I might not be able to see the chat screen at the same time, but we're going to see what happens. I'm just going to take a second to move some things out of the window so I can see the presentation mode. And okay, so in the last class, we had just started to do an exercise that looked exactly like this, and then we went through everything that was on the screen. Basically, it was a whole bunch of different items that we were seeing, and we were deciding like on one set compared to the other set. Were we a subset? Were we a proper subset, both or neither? And so we could refresh a little bit. I changed the example so that it's new, and we'll have about 2 or 3 screens of these that'll help us reacquaint with everything. And I think, let's see, Shane is next. Shane I have for number 4. So first thing it might be really helpful to do is talk about what these funny looking symbols mean. So when we see that first symbol with the C, Shane, are we thinking subset or proper subset? Which one?
I would say subset.
What do we think, everybody? I'm just pausing to get somebody into the room here. Okay, so Shane says the first one is, I think I heard you say subset. Is Shane right?
Kinda.
Okay, kinda. Tell us more.
I think that it's both.
Okay, the first, well, what I'm doing right now, just so you guys know, let me pull this back. That was my fault. The first symbol, the C, that's the symbol for a proper subset. We're just going to take a second and talk about what the symbols are.
Oh.
The second one, you're one step ahead. That's okay. With the C in the underline, what's that one stand for?
Subset?
Yeah, that's a subset. And all the underline means when I think about it is I'm able to let my subset equal the main set. And that's a nice little way to differentiate them. Okay, so back to where we were before. They're saying on the left, BCD, compared to the set on the right, BCD and F. What do we think it would be? And I'm not sure who shouted out before, but somebody spotted it. They gave us a shout out. Was it subset, proper subset, both, or neither?
It was me. I said it was both.
Okay, exactly correct. It's both. If you're a proper subset, you're automatically going to be a subset also. And remember, guys, we're reading it from left to right. Sometimes people try to go the other way, like they try to read from right to left, and it's going to get you all messed up. Okay, the next one, and let's see. This is number 5, Sophia. Sophia, this one's all yours.
Is it neither? It's the same, so like it's not a subset.
You're thinking the right way. It's not a proper subset because they're both the same. So it's going to end up being a subset. And I see somebody else is trying to join. I'm going to let one other person in, and then after that, I have to stay with the presentation because it's been, well, we're 20 minutes in already almost. Okay, so the next one, this looks like, And I got to move the chat window so I can see everybody's name. Okay, we're up to Eric, number 6.
That's both.
Okay, that one's going to be just a subset.
So,
Do you know
okay.
why? Eric, do you know why it won't be a proper subset also?
Not sure.
How come it can't be a proper subset, everyone?
Because of the same.
Yeah, exactly, correct. To be a proper subset, what's on the left has to be smaller than what's on the right, Eric. That's how you would know. So it's
Okay.
going to be a subset. And the next one is, this is Brian, number 7.
Uh,
Anybody want to help out Brian? I almost said number 7.
I
Anybody
want
want?
a subset.
It's who?
Subset?
What do we think, everyone? Is it a subset?
Is it both?
It's both.
It's actually neither. How can you tell quickly?
I mean, you're missing Tuesday.
Well, is the thing on the left bigger than the thing on the right?
Yes.
Yeah, that's how you can tell really fast. So if it's overgrown, more overgrown than the main set, it won't be able to make either subset or proper subset, basically because it has to be the same size or smaller to start to qualify. If it's not the same size or smaller, then you won't be able to make any of the criteria for subset or proper subset. And let's see, this brings us to Rashid, number 8. Rashid, this is yours.
Isn't it neither? Because it's also bigger than the one on the right.
Well done. Okay, and I gotta move something out of my way here so I can see the chat room again. Oh, okay, so now we're on the next page. And the next page, what it's gonna do, it's gonna give us all these different sets, universal space, set A, B, C, and D. And it's gonna start giving statements to us. We have to evaluate the statement to find out if it's true or false. And the first one is saying, we see this expression here, and when we see the expression, we're up at number 9 now with Richard. What's the expression reading if we read it left to right? Like A is a what of the universal space?
I'm not sure.
What do we think, everyone? What's the symbol standing for?
Proper set.
It is. It's saying A is a proper set of the universal space. And what do we think, true or false? That's for anyone that wants to answer.
True.
Okay, it's exactly correct. It's true. So Ariel, number 10 is next. This is ours for number 10.
It's true.
You are right. It's true. And Maya, number 11. This is yours, Maya. Maya, can you hear us?
Yes.
Okay, what do we think for the next example? True or false?
False.
Okay, you're correct. How did you know it was false?
Because both only had because there's no universal in for them.
Well, it's saying D is a subset of A. And when we look at D, What's in it that's preventing it from being a subset?
It's the D. Like,
It is
they both have
correct.
A.
Yeah, you're exactly right. The D is going to stop the magic, basically. And we've got another here. This is going to go to Chloe, number 12.
I'm gonna say false.
This one is true.
Okay. I have no idea. I thought because it's bigger.
In B, you have A, B, E, F, and G. And it's asking you, basically, will A fit into those letters we just read? By fit into, we mean, is it a subset? So A and E, when we look at those elements, both of those elements are in set B also, so it must be allowed to be a subset.
Gotcha.
Okay. And one thing I gotta recommend to you guys, when you get on the test, how fast do you have to be able to do the true falses, the yes and the no's, like all these different questions, like is it a subset? How fast do you think you're gonna have to respond to that stuff? Like how many seconds do you think you're gonna have to think about it when you get to the testing situation? And keep in mind, there's gonna be a lot of these. You gotta have maybe, like if you're doing the examination in the classroom, you'll have maybe 3 seconds to figure out what each one is. So if you're looking at it and you're saying, gosh, I have to look up the symbol, I have to look things up, I can't remember the term, that means you're not ready for the exam and you got a lot of review work to do. Because if you think about all the different things we talked about, like equal sets, equivalent sets, finite, infinite, cardinality, subset, proper subset, there's lots of different terms. And while the test is basically, a take-home test, you don't want it to take 8 hours to get through the exam because it's not at all going to be a fun experience. It'll be way too grueling. So just kind of notate things that you need to go and review. Sometimes you'll do the homework set and great, I did the homework by 2 o'clock. By 5 p.m., what pretty much happens? You forgot the whole thing already. So every day is going to be a continuous review to keep getting quicker and faster at it all the time. And I think we have a couple more, and we're up to now number 13 with Kevin. Kevin, can you hear us?
Is that false?
You are right. How did you know so quickly?
The order is wrong?
Well, it's not just the order. What's the big thing that's jumping out at us that makes B not fit into C?
Different letters.
It's more than different letters. I mean, well, actually, what you just said is technically correct. So yes, it has letters that are in set B that cannot be in set C. So you're right there. And B is just way too big. So if you have more elements in B than you do in C, you're automatically not going to meet any of the criteria. Just something for you to tuck under your hat. And I think we're up to, we can't see who's next, so I'm going to have to scoot down on the list here. Okay, this goes to Jake at number 19, and then we start over again from the top. We got a couple more to make sure we're primed up. Now, Jake, can you answer that without looking at it? Or, I mean, can you answer that without looking at the sets, universal space, A, B, C, and D?
True.
You're right. How did you know it so quickly? What's the empty set going to be a subset of automatically?
A.
It will be. And it's going to be automatically a subset of everything because there's nothing in the empty set that's not in any other set. So when you see that on the test, guys, it's automatically almost always going to be true. And there's one more with the null space. Everybody just shout out your answer. What do you think it is?
True.
True.
Okay, good job. What do we think of this one? And I'm going to have to scroll back to the top of the list here. This brings us back to Michael, number 1. It says there's 4 subsets of D. How can we figure out how many subsets there are? Like, what's the hard way and what's the easy way, Michael?
Isn't it like counting the number of elements?
It does have to do with that. That will be very helpful. What do we do with the card? What do we call the count of the number of elements? What's our term for that?
Finite and infinite?
No, something else. Begins with a C. There's a special word we have.
Complement?
Not complement, something else. Think of birds.
Cardinality?
Yes. Okay, I heard a couple people. It's cardinality. So what we could do is we could manually do this by brute force. Like we could go to set D. It's got 2 elements. So let's just start carving up with a pencil and paper all the elements in it. But if you have a really big set, it's going to make you pull your hair out because it's going to be way too much work to do it by brute force. So there's an easier way that we can find a number of subsets. Anybody remember what we do? Yeah, I heard somebody say use the cardinality. What do you want me to do with the cardinality?
Square it.
Okay, this is very close. What we want to do, let me bring that back. We want to go with 2 raised to the power of the cardinality. And that'll get you your answer. 2 raised to the power of 2 will be 4. But believe me, that's going to save you a ton of time on the exam. And it's probably going to be worth about 9 points because you'll have maybe 3 questions are going to give you sets. They'll be big enough to the point where you can't do it by hand. And you just have to remember that formula, 2 raised to the power of n, and you'll be home free. And let's do it just once more. For number 2, Caroline, what do we think? It says 8 proper subsets of C. This one's all you. And you have to be careful. This one does have a trap in it. And I don't hear Caroline, so I'm going to go to number 3, which is Ashley.
A false?
How did you know? What was the trap?
To be honest, I don't know. I just guessed.
Keep doing that. You're a good guesser. You have like a whole career in guessing. Okay. Anybody spot what's the trap in the question? They're not asking you for subsets. What do they want to know this time?
Proper
set.
Yeah, well done, well done. So we want to use the formula for subsets, then we have to subtract 1 to get proper subsets because the proper subset can't equal the main set. That's what makes it a false statement. A lot of people will say, oh, I need to look at set C. I have 3 elements in set C, B, F, G. 2 to the power of 3 is 8. Yes, true statement. And then what happened was they forgot the word proper was there and then they get the question wrong. So just remember subsets is one formula, 2 raised to the power, and proper subsets, you just have to modify the formula by subtracting 1. Okay. Now, before we start to go into the next set of exercises, anybody have any questions about anything we talked about so far yet? Okay. So I think we're up to number 3 here. And Ashley, we're at this one here. We have to figure out how many subsets and proper subsets are in there. What do you think? I think Ashley, we just heard from you. That's my fault. We have to go to number 4. That's Shane. Shane, can you hear us?
Yeah, sorry, Professor.
That's okay.
I'm sorry. Could you repeat the question? I didn't hear you.
Yeah, the question is right on screen. We're thinking about subsets and proper subsets. So when we see the set 1, 5, and 10, how many subsets are there and how many proper subsets? Or, excuse me.
I'm not 100% sure.
Okay. Anyone else? I see, looks like Sophia is next, but I'm going to hold off with Sophia for just a second. Anyone else want to shout out, how do we figure that out? The hint is we just did it on the last slide.
You just put 2 to the
Is one of the answers 6?
8 and 7.
Is one of the answers 8?
Yeah. One of the answers is 8. That's the number of subsets. That'll be 2 raised to the power of the cardinality. It's just 3. So
And is the other answer 7?
exactly correct. So you're going to have 8 sets. 8 subsets, 7 proper subsets. Sophia's number 5. Sophia, this one is yours. And if maybe you don't have a calculator, just tell us what the formula would look like with the numbers in it, and then that'll be okay for us.
I think it's 2 to the 7th, right?
Beautiful. Yeah, that's going to give you subsets. How about proper subsets?
127, yeah.
Outstanding. You got it one shot. Okay. So now what we're going to do is we're going to gear up for set operations. It's going to be totally different. So if you were deciding I'm sick and tired of doing these symbols, you're really going to like what comes next. Just remember each day, pull out some of the exercises from what we just talked about, the subsets, the proper subsets, the cardinality. And what you want to make sure that you could do is get to the point where you're answering the questions within like max 10 seconds. And I honestly, I firmly believe a lot of you guys did do the homework last night and you just forgot it because you probably didn't look at it right before the class started. Anyway, set operations are all about what happens when we want to take different sets and start combining them together. So far, all we've done is we've taken one set and we've said how many elements are in it. Is it infinite? Is it finite? How many subsets can I make from it? How many proper subsets? But we haven't taken other sets and combined them, added them together, subtracted them. So that's exactly what set operations are going to do. And this will help us immensely with Tuesday's lesson. Because on Tuesday, we're going to get into, I don't want to say word problems, because they're not the same thing that we did the last time in chapter 1 when we hit word problems. But they're specific kind of word problems, and we're going to end up using set theory to solve them. And we're going to need everything that we're talking about right now and yesterday to get through that. Okay, so first thing that we're going to do, first term, is something called an intersection. And when somebody is driving down the street and we see an intersection, same thing in set theory. Intersection is where 2 streets are coming together, and we're just talking about the part that's the common part to both of those streets. In set theory, it means the same thing. So we have 2 different sets, and each set we've identified with a circle using a Venn diagram. So in set A, we have 2, 1, 3, and R, like Romeo. In set B, 3R and -7. And usually what we'll do is we're going to put the name of the set on the line of the circle so you don't confuse it with an element of the set. When you're thinking about the intersection, what part of the Venn diagrams do you guys think we want to go into? Eric is number 6. Eric, what part of the diagram do you think that we want to keep our eyes peeled for when we're doing intersections?
The middle.
You are correct. We're looking straight for the middle. We want to know what's in circle A and circle B at exactly the same time. Something you have to remember is we have an abbreviation for intersections. You're going to need to know this for sure on the exam because you're going to see it everywhere on the test. It looks like a upside down U. So as soon as you see the intersection, look on both sides, see what letters that are there. And that's what you need to find the intersection of, A and B. And then we're just going to write down that the intersection is elements 3 and R. Everybody okay so far with intersection? Okay. Next thing that we're going to do is going to be a union. To be a union, you have to be in set A or set B. When we look at the diagram, the applicable area is going to be what's shaded in blue. And when we're talking about union, if we see it on homework, it's going to have the shorthand symbol of a U. That's how it'll look. The big thing that you don't want to do with a union is you don't want to duplicate anything. If we're being really quick, what do you think we probably would duplicate if we were writing the union down? What's the most common thing that people try to do by mistake? What elements probably get listed twice, like if you're in a rush?
The 3 and the R.
Exactly correct. Yeah, people try to write the 3 and R down twice. Do not do that on the test. You will lose points for that. You're going to put everything that's in A and B without duplicating, and that's it. Any questions on the union? Okay, so we're going to go through one more. It's called difference, and then we're going to put all this stuff together, and we're going to start to work it with a lot of exercises. The idea that we're doing is pretty simple, but it can get really complex when you have lots of different sets all at the same time. So the last one is a difference. And a difference is sort of like what you would think in mathematics of a difference. You're going to start subtracting stuff. That's what happens in set theory. So we express a difference with a subtraction sign. If we write down A minus B, that means we want to take all of the elements in A except the ones that are in set B. Whatever's to the right of that minus sign, I like to think of that as the no-fly zone. Like I can't touch circle B. I have to stay out of there completely. And that's going to leave me with T and 1. That's the only thing that I can touch. Any questions on how to use the difference, how to use the intersection, how to use the union? Okay, I'm just going to double check the chat window and scroll down, make sure nobody else listed a question, and they haven't. So what we're going to do is try this out with a real life exercise, see what it actually looks like. And when we do it, people have all kinds of different ways of doing this. Some people like to try to do it all in their head, which I don't really recommend because it works great until you get confused and then there's nothing to look at to try to undo the confusion or the mistake. And I have to move the chat window again because it's blocking my visibility. Okay, so we've got universal space, and then somebody made 4 elements out of the universal space, W, X, Y, and Z. Sorry, 4 sets out of the universal space. And what we need to do is we got this whole expression here. And if we're reading the expression, I've got to move the chat window again. If we're reading the expression, oops, there it goes, from left to right, I think we're up to number 14 with Patricia. How would you read that from left to right, knowing what the symbols stand for? Patricia, can you hear us?
Yeah, what was the question?
Yeah, the question was the expression we see in bold, knowing what the symbols stand for, how would you read the expression from left to right? What's it want us to do? Anybody want to help out Patricia? Oh, there she goes. What'd you say?
I'm not really sure.
So what's in the parentheses? What do we need to do there?
The union.
Yeah, it's saying union of X and Y, and then what do we need to do with that union?
Get the intersection of Z.
Right on. So it's union X, union Y intersected with Z. And when we see an expression in mathematics with parentheses, where do you guys think we probably want to start working first?
Parentheses.
Yeah, we're probably going to hit the parentheses first. So let's start to roll that out. I'm going to make kind of a dividing line here so we don't get too confused. This is our set theory ninja. It's going to help us out a little bit. And the first thing I'm going to do is I'm going to go ahead. I'm going to write down all the elements that are in Y. Reading this left to right, I probably should have started with X. Now, to keep things nice and separated, what I'm going to do is I'm going to take the elements in X and I'm going to list them right under if they appear for Y, where they appear, If they're not also part of y, I'm going to write them off in a space to the right of where everything's listed in set y. And I do that just to help separate things. A lot of people try to do this in their head, and if you can, that's great. Like, you're going to be a set theory specialist. But in the beginning, it might be better to be a little more cautious. So, for example, set x has a 1 in it, and I see y has a set 1. So I'm going to put the x right under the 1 in set y. What elements were in set x that were not in set y? This is for Camila, number 16. Oh, sorry, I skipped Halen, number 15. Halen, what stuff was in X that wasn't in Y?
2, 4, and 6.
Well, what they have to be, if they're elements of X though, like what elements were in X that you couldn't find in Y?
7, 9, 11.
And then stop. You got it.
And then that's it.
Okay, so I'm gonna work with Halen here. So what I'm gonna do is draw a line here, separate out. And Halen, I know that we have to do a union. So when we look up there, what we're gonna do is we're thinking of union. What's the union have to do, Halen? What's the definition of it?
An element that is in set A or set B.
Exactly correct. Well done. I'm going to go ahead. I'm going to sweep from left to right. I'm going to write down all the numbers that I see. And I'm going to get 1, 2, 3, 4, 5, 6, 7, 9, and 11. Everybody okay so far? All right. So now that I've done that, the next thing I have to start to do, we need to start thinking about Z. I'm going to do the same thing I did again. I'm going to take all the elements in set Z and I'm going to list them right down on the sheet. If they also appear in Y, I'm going to put them directly where they are for Y. And let's see. This is Camila, number 16. So Camila's next. What's our intersection definition, Camila? What do we need to do? Camila, are you mic'd in?
Yeah, I have no idea.
Okay, so Camila needs a lifeline. What do we think, everyone? What's the intersection going to tell us to do?
Find the ones that they all have in common.
Exactly correct, yes. Find everything that's in set Y and Z. So if we know that, Camila, which ones are we going to walk away with for the intersection?
Two, 5, 6, 11.
It is, yeah. Easiest way to do it might be just to look at the two lines, set Y and set Z, take the double-decker elements, like the elements that appear twice, and we're going to walk away with 2, 5, 6, and 11. That's going to be our final answer. How does everybody feel? Okay with the set operations so far? We'll do a little bit more practice because we still have time, but I just want to see if everybody's feeling pretty good. Anybody has any questions? Okay, so you guys want to try one on your own. What do we think?
Yeah.
All right, here we go. So this is our next one, and it's a little different than the last one. I'm going to give you guys, let's say, 2 minutes to think on it, and then we'll see what we get. And if anybody has questions, feel free to go ahead and type them into the chat window there. I'm going to set my stopwatch for 2 minutes so I remember too. And if you think you got the answer, go ahead and shout it right out too. If everybody's shouting out the same thing, we'll know that's probably the answer.
Is the answer 3?
We've got 1 vote for 3. I don't remember 3 is the answer. So we'll start to find out soon, and then eventually we're going to work through it. Got about a minute left, just so you know where time is. There's about 20 more seconds. Anybody need another minute or two? Just shout out and say, wait, you're going too fast, and then I'll know. What answers did everyone else get?
Is it null?
Is it the end?
Where is it?
Okay, I heard one person say, is it the null space? Anybody else? We had one person said they got 3. What's one thing that we had to remember, or we would just be on SOS, like save
They
our.
had to be, and they both had to be in the same set and B, but
This is true. Definitely.
there's not anything in like for W and X. There isn't.
So
That maybe that I'm missing. I'm probably missing it.
well, you're talking about the intersection definition, and we can't get the solution without knowing what the intersection is. So you're definitely thinking the right way. Can we just take W and X and intersect them, and then we're done? Will that work?
No.
Exactly wrong. Yeah, that's not going to work. Why won't it work? What's in there that's going to stop us for a minute?
The apostrophes?
Right. Great job. The apostrophes. What are the apostrophes telling us to do?
Take the complement.
Right. Yeah. So if you remembered complement, great job. You remembered what to do when you see that. So let's find out what happens when we work this through. I'm going to make a line to divide out the screen. And first thing I'm going to do is I need to bring back my universal space. Once I've got that, I'm going to go ahead. I'm going to list all the elements for W in there. And when I see complement is going to tell me that I have to take all of the elements that are in the universal space, but where don't they appear? And I'm going to go to number 18. That's one. Where can't they be one if they're going to qualify as complement? One, is your audio working? I'm going to go to Jake, number 19.
Can you repeat the question?
For sure. Yeah, we're thinking about the complement. So a complement is going to be all the elements in U that don't appear where else?
In X.
Okay, W, which is, you're thinking the right way. So to get those, I'm going to notice the 1 does not appear in W. That's going to be part of the complement. The 3 does not appear in W. The 5 doesn't appear in W, and all the way down the line. So at the end, my complement is going to be 1, 3, 5, 7, 9, and 11. Was everybody able to get that far? Like anybody confused on that?
Wait, so when they got the apostrophe, I have to use the U?
Exactly. Well, you have to do the complement thing. Yes, you're correct. When you said U, I was thinking of union, but you meant universal space.
Yeah.
You are right.
All right.
Okay, I'm going to circle that so I'll be able to go back to it more clearly shortly. Next thing I have to do is work on the complement of X. And to get the complement for X, I end up with 2, 4, 6, 8, 10, and 12. Questions so far up to where we are? Okay, I'm going to circle this because there's a lot of traffic on the screen. The last thing I probably need to do is going to be what? How do I take what's circled in both places? What am I going to do with those things? And as for anybody that wants to answer, just go ahead and shout out.
See what they have in common.
Yeah, exactly. I have to see what they have in common. When we're looking at them, what elements are in one that are in the other? Well, the way that I can do that a little more easily, I'm going to stack them up next to each other. And when I compare, we're looking at the elements in the complement of each one. Are there any that seem to be in common? I hit the button too soon.
No.
No, we don't. So I'm going to end up with the null set for our final answer. Now, you'll probably have close to maybe 5 of these questions on the exam. I'm going to throw out like a universal space and 3 or 4 subsets of that, and you're going to have all kinds of different expressions. So make sure that you remember how to handle the expressions and how to evaluate them. And usually each one's worth about 5 points. So if you have the whole section, you're feeling good on that, that's like 15 points right in your pocket that I'm just giving you for knowing how to do the intersections and unions and the complements. What do we think? Should we do one more? Send me in the text message, right? In the chat window, give me a message if you're like thumbs up, you're feeling good, or you're saying like, oh my gosh, I'm on overload now, just so I know where you guys are. Because I can't see everybody, we're not in the classroom. So I want to just check in a little bit.
Can we do another problem, just please?
Yeah, Okay, a couple people are asking. So I've got 2 people that are saying do more. We're gonna go ahead and do more. We have the time. We'll probably do like 1 more good one, maybe 2, and then we'll start to wrap up. We'll talk about what we need to know for next week. Okay, so this is our next one. I'm gonna give you guys, we'll say 3 minutes to work through it, and then we'll start to put it up on the screen. I'm gonna set my alarm for 3 minutes. And 1 more minute. All right. Who's got something? What do we think? If you want to go ahead and use the microphone and just shout out what you got, go ahead. Or if you want to type it into the chat room too, you could just give me your elements and we'll see how it turns out. I'm going to, let's see, I'm going to break out of this screen here so I can see the chat window more visibly. Does anybody need another minute or two? Because I'm not seeing anything happen. Oh, here we go. Here they come in. B, D, F, and G we've got. And I think the answer just went up on the screen too. Okay, Albert is correct. It is B, D, F, and G. And I'm going to put it up on the screen with our the solution here so we can check out how that happened.